Hello learners, welcome to the world of mathematics. In the previous class, we have learned about a very beautiful method which is called the Wavy curve method, and in this class we are going to learn about inequalities in general. Inequalities is a very fundamental concept, and we are going to get a lot of questions on solving inequalities. Inequalities independently may not be coming for a lot of exams, etc., but it would be a part of a larger question. So let us learn about inequalities in general. Now, how to solve inequalities? The rules are pretty simple, and we have been learning about these rules from quite some time now. And in our 8th class and 9th class, etc., or standards, which we have already done some of the inequalities, etc., and at least the linear inequalities. So the rules, etc., which were learnt there are going to be applied here as well. So, but for the sake of completion, I'm actually expressing those rules also here, so that we are not leaving anything aside. So adding or subtracting same quantity on both the sides of the inequality does not change the sign. So if I say A is greater than B, and if I add C on both the sides, it's all okay. If I subtract C from both the side, then also it is completely okay. So adding or subtracting the same quantity on both the sides is completely okay. Will not change the sign. The sign will remain as is. Now multiplying and dividing by a positive number. So if we already know that the number which you are multiplying with is positive, then it's completely fine. The inequality will be retained. So Ka will come out to be equal to greater than Kb. If A is greater than B, then K of A, K into A will come out to be greater than K into B if K is positive. But if K is negative, then K into A will turn out to be less than K into B if K is negative. So we have to be very careful while dealing with this. So in the last class also we talked about one of the questions where we clearly said that okay, we are not going to multiply x throughout. Why? Because we don't know whether x is going to be positive or negative. And whenever such a situation is there, please don't try to multiply throughout. Bring it to one side and then solve it. If the sign of the multiplier is already known, then it is not a problem. Then we can actually write the inequalities very clearly in this fashion. So if x is greater than y, minus x will be less than minus y. Also reciprocating the expressions is also going to reverse the sign. So if x is greater than y, then 1 by x is going to be less than 1 by y. So we have to be very careful here, particularly in this and this. These are key statements altogether. So that's why what I've said in this statement is never multiply throughout by a variable, because we don't know the sign of the variable. If we are sure of the sign of the variable, we can manipulate as per the above rules. So we have to be very careful around it. Although these inequalities can be arrived through wavy curve method, okay, but these occur so frequently that these are expressed separately also. So it's better to go through these. So x minus a into x minus b less than 0, then x belongs to a comma b with open interval a comma b. So if x minus a into x minus b is less than equal to 0, then also it's fine. X will belong to closed interval a comma b. So that is completely okay. But the idea is that x will lie between a and b. But x minus a into x minus b is greater than 0, then x will lie outside a and outside b. So if we are expressing it on the number line a and b, okay, then x will lie here and here. It will not lie here. So we have to be very careful. We have to, it's sometimes okay to remember these intervals also, so that we can solve the questions very quickly. Whenever x square is less than equal to a square, it is similar to what we have seen in the first expression, where b will come out to be equal to a. So this will come out to be from minus a to a. And x square greater than equal to a square. Similarly, what we can do is we can always solve it through Wavy curve method, but these expressions come too frequently, and hence these are given to you separately. Also, one very important thing is fx plus 1 by fx. So if an expression and its reciprocal is added, it will always come out to be either greater than equal to 2 if fx is positive. If we know for the fact that fx is going to be positive, then this expression will come out to be greater than equal to 2. And if this fx is known to be negative, then fx plus 1 by fx will be always less than equal to minus 2. It will never ever take any value between minus 2 and 2. It will not take any value between this interval. So if you write x plus 1 by x, it will always come out to be greater than equal to 2. The equal to sign actually will hold when both of them are going to be equal to 1. So x equal to 1 will hold the equal to sign. Otherwise, for any value of x, say you take x equals to 0.1, then also this will be 0.1 plus 1 by 0.1, which would be 10 plus 0.1, 10.1, which is much greater than 2. And similarly, if you take high value of x also, then also it will come out to be greater than 2. Similarly, if you take the value of x to be negative number, then x plus 1 by x will come out to be less than or equal to minus 2. So if x is negative, howsoever small or big, it will come out to be less than or equal to minus 2. The equal to sign will hold when x is equals to minus 1. Moving ahead. Now, let us talk about inequalities involving modulus functions as well. So, whenever there is a modulus function involved, let us try to solve these inequalities in a quick manner. What we can do is we can remove the modulus sign, because it is generally difficult to solve the problems with the modulus sign. So, what we can do is we can remove the modulus sign in this manner. So, whenever x minus a is less than b, then we can actually express x minus a is between b and minus b. If there is an equal to sign, then we will put, so there is some mistake here. There should not be equal to sign here. Okay. So if x minus a is less than b, then x minus a should be between minus b and b. If there is an equal to sign, x minus a is less than equal to b, then it would be minus b less than equal to x minus a is less than equal to b. Okay. Now for mod of x minus a greater than b, again there won't be equal to sign here. X minus a will be less than minus b, or, which is a union, or x minus a is greater than b. So we have to be very careful. X minus a has to be less than minus b, or x minus a has to be greater than b. This is also a very important inequality in itself to solve a lot of problems. This part of the problem is called triangle inequality, and this is a very important concept. We should always remember this. This tilde sign is the difference sign. So whatever is greater of x and y, mod x and mod y, will be taken first. So the output to this will always come out to be a positive number. So mod of x plus y or x minus y will always be will be greater than equal to mod x difference mod y, and will be less than equal to mod x plus mod y. We have to be very careful around this inequality, and this is the inequality which can be used like multiple times in a lot of questions. The equality in this expression, in this inequality, I should not say expression, this is an inequality, equal to sign in this inequality holds when x and y are of the same sign. If both x and y are positive, both x and y are positive, then also the equal to sign will hold. That means mod x difference mod y will come out to be equal to mod x plus or minus mod y is equal to mod x plus mod y. Okay, so basically we can say that mod of x plus y is equal to mod x plus mod y whenever x and y both are positive. X and y both are positive, or x and y both are negative. Okay, so if both x and y are negative, then also the equal to sign will hold. So this is an important expression altogether, uh, which we need to remember. Another one is how to solve modulus sign in general is to basically break it into the intervals. So whenever you are confused at how to solve the modulus sign or modulus inequality, what we need to do is we need to break it into uh, individual uh, intervals. So mod is there with x plus 3. So what I'll do is one of the keys will be x is less than minus 3 and x is greater than 3. For x less than minus 3, this will come out to be a negative number. So I can write it as minus of x plus 3 plus x divided by x plus 2 is greater than 1. And for this case, I can write it as x plus 3 plus x divided by x plus 2 is greater than 1. Of course, we can solve these inequalities, both the inequalities separately, and get the answers here. I'm not getting involved into the solution of these inequalities altogether, but I'm more focused on how to remove the modulus sign in general. So basically, you will get some values of x from here. Okay, take its and you will get some values of x from here. Take the intersection of these values, intersection of these values with these values. Okay, so if any value of x is coming out to be say greater than minus 3, we have to discard it away. So we have to take the intersection of the values of x with this. Similarly, we have to take the intersection of these values with this, and whatever solution is coming here and coming here, you have to take the union of it. So these are the two cases. Case 1 is x is less than minus 3. Case 2 is x is greater than 3. And then we have to find out the values of x, take the intersection of with the initial condition so that we are remaining within the domain. So this is the domain condition now becomes, right? So we remain within the domain. In this case also we remain within the domain, and then whatever values of x are coming finally within the domain, here and here we take the union of it. We have to be very, very careful around this. Similarly, for such kind of questions also, what we need to do is there are two modulus signs. We have to, and these are two different modulus signs. So we have to break the interval into two parts or three parts, I would say. 1, 2. So I'll find out the factor of this. I'll find out the factor of this. The factor of this is 1. Factor of this is 2. What I'll do is I'll take the conditions for x less than 1, x between 1 and 2, and x greater than 2. For any one of these cases, you have to take the equal to sign also. So let us say we take the equal to sign here. In this case, I can take x is less than 1, 1 is less than equal to x is less than equal to 2, and x is greater than 2. We can take equal to sign anywhere, actually, any one of at any one of the points. Once taken, it will be taken care of. Okay, so we have to solve it 3 times. One for this condition, case 1, case 2, and case 3, and find out the inequality. So for case 1, say this is case 1. Okay, I'll write the expression as minus x minus 1 minus x minus 2 is greater than equal to 4. For case 2, it will come out to be for 1 between 1 and 2, this is positive, so it would be x minus 1 itself, but this is negative, which is minus x minus 2 is greater than equal to 4. I'll solve it. Actually, let me try to solve this thing. This will come out to be equal to 2 minus 1 is greater than equal to 4. which is never possible. Never possible. So there are no values of x for which is lying in between this interval for which you will get a value which is satisfying this inequality. So there are no solution here phi. There is no solution in this interval. There would be some solution which would be coming out from this interval. Let me try to do it quickly. Minus 2x plus 1 plus 2 is plus 3 is greater than equal to 4. Minus 2x is greater than equal to 1, or x is less than equal to minus 1 by 2. Remember, I am dividing by a negative number. That's why the inequality changes. Okay. This solution is saying x is less than equal to minus 1 by 2. I have the domain condition of less than 1. So this will prevail. So x will be less than equal to minus 1 by 2 from this. And from this condition, I'll again do it. I'll just change the ink quickly. Okay. I'll change it and do this problem also. For x greater than 2, this is positive, this is positive. So it would be x minus 1 plus x minus 2 is greater than equal to 4. So this will come out to be 2x is greater than equal to 7, x is greater than equal to 7 by 2. So this is a prime condition for x greater than 2, x greater than equal, what is the intersection between the two? X is greater than equal to 7 by 2. So the answer to this problem is x belongs to minus infinity to minus 1 by 2, close bracket because there is an equal to sign, union, and close bracket 7 by 2 to infinity. So this is the solution of this kind of an expression. What we have done is we have broken down into three cases, took the union of the three cases. This case is giving you no solution at all. This case is giving you one solution. This case is giving you one solution. I have taken the union of all of them. So I have actually solved this question already. So we can solve such kind of questions easily. This is the easy case, and this is what I was also talking about. Is generally the problems related to these modulus signs are going to be lengthy, and the JE question setters are smart. They don't want to give you lengthy questions. They want to give you smart questions. So you will get a lot of questions like mod x plus mod y equals to mod of x plus y. Now these kind of expressions you have to be very careful here. As you can see here, x minus 1 plus x minus 2 is equals to 2x minus 3. So x plus y is equals to mod of x plus y. Whenever such a kind of situation happens, as I've already told you, for such equal to sign to hold, x and y should be positive. That means in this case, x minus 1 should be x minus 1 and x minus 2 should be of same sign. X minus 1 and x minus 2 should be of same sign. That means both should be positive or both should be negative. In both the cases, the multiplication of them should be positive. So I'll just solve this. And get the answer out of it. So I'll quickly solve it. X equal to 1, x equal to 2. For very high value of x, this is positive, negative, positive. So x belongs to minus infinity to 1 union 2 to infinity. Now, since there is an equal to sign, I'll include both the signs also. I'll put the equal to sign here. Okay, so it would be minus infinity to 1 union 2 to infinity. Similarly, in this case, this might not look like x minus 1 plus x minus 2 is not equal to 3. But actually, what would be the case here? I can write this as x minus 1 mod of it plus 2 minus x, or I can write this as 1 minus x plus 2 minus x is equal to 3. Now, so this I need to actually express properly in the broken form altogether. I have to break the intervals into 1, 2 and solve it 1, 2 and solve it properly. making three cases: this case, and this case. That's it. Okay. So one of the questions here: find the set of real values of alpha for which this and this is equal to this has more than two solutions. Now, since it has more than two solutions, that means, and it's an equal to sign, right? And it has many solutions. Generally, equal to sign will have only one solution, and since mod is involved, we can expect two solutions. But then they are saying that it has more than two solutions. That means basically this inequality is is holding up for multiple values of x. So what is the value of alpha? What we can do is, basically, this is something like mod x plus mod y equals to mod of x plus y. So basically in this case, the this can be written as 5 minus 4x plus 4x plus 5 is equals to alpha x plus 10, and this on adding up will give you 10, right? So alpha will come out to be equal to 0. So alpha is going to come out to be equal to 0 if it has more than two solutions. Okay, so we can do such kind of questions also very easily. The last part is the trigonometric functions. We have to be a bit more careful here. We can easily solve these inequalities, etc., because we know that sin x is going to be between minus 1 and 1, cos x is going to be between minus 1 and 1, and cosec and sec follow less than equal to minus 1 or greater than equal to 1, right? So such kind of inequalities can also be solved, but we have to be little bit more careful because these have these conditions in it. That's it in inequalities. Thank you for going through this topic. Join us for our regular weekend batch. You can send out all these details over this email, and we'll take it up. Please do like, comment, subscribe, share, and turn on notifications to get similar kind of videos continuously. Thank you.